Good morning, students. Today we are discussing about new concept of stack. Okay, what is stack? Stack is a linear data structure that follows LIFO principle. Stack is a linear data structure. A stack is a linear data structure that follows the LIFO, last in first out principle. Stack has one end only. Stack has only one end. Other end is closed. Stack has one end only. Other end has closed. Whereas queue has two ends, front and rear. Queue line lo ela nunchuntamu. Last in first out. That is called queue data structure. Yesterday we learned single linked list operations. Insertion at first, insertion at last. We discussed in the last class. So insertion at first means stack data structure. Okay. Insertion at first. Insertion at last is a queue data structure. Okay. So today we learn stack data structure. Okay. Now in stack data structure, only one end is open, other end is closed. Okay. And queue data structure, both ends are open. Is there. One is front end and another one is rear. Insertion is will happen at rear side. Deletion will happen at front side. Whereas in queue. Now coming to the stack, insertion and deletion both are will happen at same end. Because one end is closed enough. That is the reason. Whenever an element is added in the stack, it is added to the top of the stack. And the element can be deleted from the stack in other end. From the same side. Stack can be defined as container in which insertion and deletion can be done from the one end only. Okay. Only one end. So please look at this diagram. This is a stack data structure. This is a stack data structure. This is a stack. Insertion will happen at this side. Deletion also same side. Insertion and deletion both are will happen at one end only. That is called stack data structure. If you want to insert an element into the stack is called which operation? Push. That is called, if you want to insert an element 1 into the stack, that is called push. If you want to insert another element, that is called push 2. If you want to insert another element 3, push 3. If you want to insert another element, push 4. If you want to insert another element, push 5. So, any data structure, 5 operations are common. Insertion, deletion, updation, display, and search operations. So, coming to the stack data structure, which follows last in first out principle. Stack follows which principle? LIFO, last in first out principle. So, if you want to insert an element into the stack is called which operation? Push operation. PUSH, push. So, please chart. If you want to insert an element into the stack, that operation is called as, please chart. If you want to insert an element into the stack, that operation is called as, please chart, push operation. Very good. Very good. Very good. Okay. I am asking another question. In stack data structure which follows which principle? LIFO or FIFO? Last in first out or first in first out? In stack data structure which follows which principle? Last in first out or first in first out? LIFO. Very good. Very good. If you want to delete an element, if you want to delete an element, if you want to delete an element from the stack is called if you want to delete an element from the stack is called pop. Very good. So this is called pop. So okay, pop 40 means 40 is deleted. Pop 30 is deleted. Pop 20 is deleted. Pop 10 is deleted. So there is an element in the stack. So if you want to insert an element is called push operation. If you want to delete an element from the stack is called pop operation. Insertion and deletion both are will happen to same side. So that is called top of the stack only. So that is called top of the stack only. Insertion and deletion will happen at top of the stack only. Because one end is closed. Because one end is closed. So these are the operations in standard stack operations. Push operation for insertion, pop operation for deletion. So first, if you want to insert an element, first we check the stack is empty or not. E is empty function. For stack is empty, then only possible to insert an element. Okay. E is full. Sorry, E is empty means if you want to delete an element from the stack, if it is empty, deletion is possible? No, because stack is empty, deletion is not possible because there is no element in the stack. E is full function. It determines whether the stack is full or not. The stack is full. If you at that time, if it is possible to insert an element into the stack, no. Okay, like peak, it returns the element given at position. Count, it returns the total number of elements available in the stack. Change, it changes the element at the given position. Display, it prints all the elements available in the stack. Okay, these are the standard stack operations. Standard stack operations. So push operation, when you insert an element in the stack, and then operation known as push operation. If the stack is full, then the overflow condition occurs. Okay, if it is full on counting, it is not possible to insert an element into the stack. Pop function, when we delete an element from the stack, the operation is known as pop. If the stack is empty, means that no element exists in the stack. That no element exists in the stack. This state is known as underflow state. E is empty. E is empty function, it determines whether the stack is empty or not. E is full function, it determines whether the stack is full or not. Peak, it returns the element at the given position. Count, it returns the total number of elements available in a stack. Changes the element at the given position. So these are the basic operations of the stack operations. Okay. Next. Some key relation. For example, stack. It is called a stack because it behaves like a real world stack. Files of files of books, etc. Stack is an abstract data type, predefined capacity, which means that it can store the elements of a limited size. It is a data structure that allows some order into insert an element or delete. Okay, LIFO principle. Last in, first out principle. So push operation. So first, to learn the push operation. What is push? Insertion operation. These are the terms are very, very important. When you are writing an exam, insert an element into the stack, that is not correct. Push only. Can use the word Function name is push for inserting an element into the stack is called push. Okay. Whereas in queue data structure, if you want to insert an element into the queue is called NQ operation. NQ. NQ means entering into the queue. If you want to delete an element from the queue is called DQ. Delete an element from the queue. Like this, these terminologies are very, very important to write an exam. These words are used in queue data structure. We will get a lose your marks. Okay, NQ operation, DQ operations are right in stack of stack question. We lose marks in stack like that. So terminologies are very, very important. You can use push operation, pop operation. These terminologies are used in stack data structure only. NQ operation, DQ operation, like that. Those type of word terminologies are used in Q data structure only. Don't confuse and write it as the same. You will lose your marks. Okay. Both the cases push. In this case, push means insertion element. At that case, NQ is the insertion element. In this case, pop is delete an element. At the Q data structure, DQ is a delete an element. Like, but we don't write these terminologies in this and these terminologies in that, we lose your marks. So it is very, very important. Stack follows LIFO principle, last in, first out principle. Okay. So push operation. First, we have to know the push operation. The steps involved in push operation given below. Please observe the push operation steps one by one. These are the important steps. These are the steps are very important. Before inserting an element into a stack, we check the stack is full or not. Before inserting an element into a stack, we check whether the stack is full or not. First, we have to check. If it is full, it is not possible to insert an element. Okay. Next, if you try to insert the element in a stack and the stack is full, then overflow conditions occurs. When we initialize a stack, we set the value of top is -1 or 0. Like this, anyone as your wish. మీరు టాప్ ఈక్వల్ టు -1 తీసుకోవచ్చు, టాప్ ఈక్వల్ టు 0 అని తీసుకోవచ్చు, no problem. Okay. When the new element is pushed into the stack, if you want to insert an element, new element, the top of the top will be increased by 1. If top reaches to the size of the maximum size, it reaches the max size of the array. It implies the stack is full. Okay. If you want to insert an element, please observe in this diagram. Please observe. So the first one is empty stack. There is no element in the stack in this stack. Now, what is the top value? Please chart. What is the top value? What is the top value? Please chart. Please chart. What is the top value? All of listen. -1. Very good. Now, after push of 10, please observe this diagram. Push of 10. After insert 10 into the stack. Now, what is the stack top value? Top increased by 1. After inserting an element, top equal to top plus 1. Top equal to top plus 1. Always you are inserting an element, the top will be increased by 1. Now, after inserting another element, push of 20. What is the top value? Please chart. Now, what is the top value? 1. 2 is not correct. 1 is correct. Next, push of 30. Now, what is the top value? What is the top value? Two is correct. Like this. So Because we are inserting and deleting, both will happen at the top of the stack only. If you want to delete an element, the top will be decreased by 1. If you want to insert an element into the top will be increased by 1. Delete, top will be decreased by 1. You got my point? We got my point? Stack linked list operation implementation. All of listen. Stack implementation using linked list. Please observe. What are the operations are there? Push, push, pop, clear stack, top. Okay. Please observe. I am inserting values 10. Push. Now top is 10. Setting 20. Now top is 20. Now I am setting 30. Now top is 30. So top will be increased by 1. Now I am setting 40. Top is changed to move to 1. Next. Now I am setting 50. Top is moved to 50. So if you are inserting an element, the top will be increased by 1. Okay. So if you want to delete an element from the stack, which element is deleted first? 50 or 10? Please chart. Now I want to delete an element from the stack. In this element, in this stack have 50, 40, 30, 20, 10 is there. Now I want to delete an element from the stack. Which element is deleted first? Which element is deleted first? 50. Very good. The top of the stack is removed first. That is the principle of stack data structure. Last in, first out. Last in, first out means last. We will came into the list. 50 is entered in the list last. So that is deleted first. Now I am clicking pop operation. Please observe. Top will be decreased by 1. Top will be decreased by 1. Pop. Now what is the top now? Now what is the top? Please chart. Now what is the top? So now I want to delete an element of this stack. Which element is deleted? Which element is deleted? 40. Very good. Next 30. Next pop 20. Next 10. Okay. This is stack data structure. It's clear or any doubts? It's clear or any doubts? Okay. So I will share this material to you. 26, 27, 28, 29, 30, I am not taking classes. 5 days I am giving rest to you. So please, I will give assignments to you. One is stack data structure, one is single linked list operations, and time complexity, space complexity. Okay, types of data structures. I will give the questions to you. Please write an assignments. After opening the college, submit to me. Okay, is it clear? Please chart. Okay, I will share the questions and answers. Okay, thank you.